In part C of example 2, we have f of x is equal to, highlight that for you, the opposite of 2 to the x minus 1 plus 3. When we graph this, we're going to graph the parent function, and the parent function for this particular uh, equation is y is equal to 2 to the x power. If we graph y is equal to 2 to the x power, the point 0, 1 is definitely on that graph. After all, 2 to the 0 is equal to 1. 2 to the first power is equal to 2, so 1 comma 2 is a point on the graph. When x is 2, 2 squared is 4, so the point 2, 4 is on the graph. And it appears that we're just doubling all the y values, which is actually true. If we move to the left, when x is negative 1, 2 to the negative 1 power is 1 over 2 to the first, or a half. And we're just going to keep cutting those y values in half. So our y value here would be a quarter, and then an eighth, and then a 16th, and so on and so forth. So that parent function graph looks a little bit like this. We can now take a look at our transformations and figure out how to make the blue graph, or f of x, from the red graph. So let's take a look at those transformations. First of all, let's take a look at the negative sign, which is right here, and that's going to be a reflection. Oopsies. That'll be a reflection over the x-axis. And then we have a shift here. Now I'm going to look at the number that's being added or subtracted to the x. That's a minus 1, so we're going to have a shift right 1, and then up 3. So let's take that anchor point 0, 1. We're going to reflect over the x-axis, so that point now becomes 0, negative 1. And then we're going to want to move right 1 up 3. So if we move right 1 up 3, there's your right 1, and there's your up 3. That point actually is right here on the red graph, and that's okay. The red graph is just the helper graph, and some of the points may be the same, but for this one, most will not be. If I take a look at the point 1, 2 and reflect that, it becomes 1, negative 2, and I'm once again going to shift right 1 up 3. So that point now becomes the point that I just graphed at 2, 1. 2, 4, if you reflect that, would be 2, negative 4. And we're going to move that now, or translate or shift right 1 up 3. So that point now becomes this point here. To draw the rest of the graph, it might be helpful to take a look at the horizontal asymptote, which is definitely y is equal to 3 for this one. That's just the vertical shift, which was up 3. So if you want, you can draw like a dashed line or a light line. That's fine. And that's going to be our horizontal asymptote. So we can see as we move to the left, those y values just keep getting closer and closer and closer. You can also shift all of them. And then I can actually move to the right as well. I can see that this distance to that asymptote is 4. So the next distance, if I move right 1, has to be 8. So I'm going to count down 8. The next one would be 16 and 32 and so on. That's what the 2 is doing with this equation. So I'm going to go ahead and graph this guy. And let's see if I can do a good job here. Graphing that. There we go. It's pretty good. Let's go through our key features together then. So our growth rate is actually 2. So whenever that base is bigger than 1, that's going to be a growth rate. Horizontal asymptote we already have. Our domain for every one of these exponentials is negative infinity to infinity. The x value can be anything. Can be an irrational number, could be pi, could be the square root of 2, could be an integer, could be a decimal. Anything will work. That's not true for the range. So the range are the possible y values, and every y value from negative infinity up to, but not including 3, is possible on that blue graph. The x-intercept is actually going to be this point right here. And that x-intercept's a little tougher to find. However, we can do that algebraically by setting the equation equal to 0, or making y 0, I should say. That's our f of x. That's right here. So that's our output. Our output has to be 0 if we're on the x-axis. So we'll go with the opposite of 2 to the x minus 1, then plus 3. Oops, that should be a plus sign. There you go. So if we subtract 3 from each side, we wind up with negative 3 being equal to negative 2 to the x minus 1. Dividing by negative 1, those negative signs will be positive. So we'll have, whoops, and that should be a 2 right there. and then the x minus 1. Now those bases aren't the same, so this is a great spot for a logarithm. So we've got log base 2 of 3 is equal to x minus 1. Check out a previous lesson for more info on logarithms. And then we've got 1 plus log base 2 of 3, and that's equal to x. So if we type that in our calculator, we're going to wind up with a number, and that's going to be about 2.6. So we can write x is about 2.6. If we look at the graph, that looks pretty appropriate there. That looks like that could be about 2.6. So there's my x-intercept, 2.6 comma 0. My y-intercept appears to be right here, and that looks like about 2.5. We'll verify that algebraically here in a second. So we've got 2.5 for that one. So there's your x-intercept. Your y-intercept will do over here. For your y-intercept, the value of x will be 0. So we wind up with a setup like this here. And we've got y is equal to the opposite of 2 to the negative 1, which is actually 1/2. So 0 minus 1 right here is negative 1, and 2 to the negative 1 power is 1/2 plus 3. And negative 1/2 and 3 is definitely 2.5. So there's your y-intercept. In terms of the end behavior, as x approaches infinity, the y values just keep going down and down and down. And as x approaches negative infinity, the y values approach or get closer to 3. So we want to list our end behavior as x approaches negative infinity, f of x would approach 3.